Hi, welcome to my talk about browser and web security and how it evolved over time. As you see, it's called We're Struggling to Keep Up. So first of all, something very brief about me. My name is Frederik, and as Jed already said, I work for Mozilla in Berlin. I have an email address and so on, if you are that interested in it. But why am I here? Well, I want to make the web a bit more secure. And I hope I can do this by educating you a bit more about security and make you a bit more sensitive about this. So as it reads here in the Mozilla Manifesto, principle number 5, I think that individual security and privacy on the internet are fundamental, and they must not be treated as optional. So let's dive in. What am I going to talk about? I'll give you a quick introduction, and then I will go through past, present, or future of security features which are implemented in the browser for you as application developers. So first of all, the web and the browser. I work for Mozilla, and everybody says and keeps on saying in meetings and big meetings, and the web is the platform. I get to hear it every day, and it's true. I mean, the web is, of course, not going away, and it's becoming more and more feature-rich. So I don't know if you recall HTML4, or, I mean, HTML stands for hypertext, right, which is text linking to text. Yeah, that's not what the web is like today. The web is experienced through rich applications like Gmail, Twitter, Facebook. And there's a neat graph that shows how web APIs have developed. This is a screenshot from Evolution of the Web. And I don't need you to read all of this because it's really small. But the high-level picture you should get is it has developed and evolved a lot. So for example, there is HTML5, of course, which contains stuff like canvas, full screen, XML HTTP request 2, and all these things that you need for rich applications on the web. And that, of course, leaves us with the topic cross-site scripting. And cross-site scripting is actually like the buffer overflow was in the 1990s. In the 1990s, every application or most server-side application was more or less vulnerable to some sort of buffer overflow vulnerability. But since 2007, the most common vulnerability in applications seen overall vulnerabilities are cross-site scripting applications. And that's not because, that's not for an arbitrary reason. It is because the most popular applications are web applications. And that doesn't just leave us with a tiny alert box or somebody stealing your cookies in your desktop browser. It's also in your phone, on your TV, and maybe even on the plane you've used to come here. And given all these API-rich HTML5 application platforms and browser extensions and Chrome apps, cross-site scripting is much more than just these tiny alert box, but it's actually some way to control all these devices. Hopefully not a plane, though. But it could make your car stop, or I do know it can make your phone ring, because, well, there are phones which do that. So let's go on and talk about the past of browser security. I want to talk about authentication, authorization, HTTPS, and frames. First of all, let's recap. HTTP used to be stateless, right? You issue a request to a server, and you get a response. And then you may do that again, and you get another response. And the server doesn't even know who you are, and it doesn't care. It doesn't retain state. And will probably not even remember that you're the same person as previously. This was solved with cookies, as you hopefully all know. The server generates some sort of ID, and you keep on sending it to the server, so the server is able to keep track who you are and what you're doing, especially for sessions and logins. But one of the problems here is everything is sent in the clear. It is sent over plain text, and if you're using a public Wi-Fi, for example, in a coffee shop or something, it basically exposes all the authentication data and even more, possibly other confidential stuff like bank statements. So, as we all know, the solution to that is HTTPS, which some people say it's expensive, but I want to say it is really not. I have a website, and I use it for non-web application purposes, and I have a HTTPS way to get in there. Because there are certificate authorities that give you certificates for free. And also, Google will rank you higher if you're using HTTPS on your website instead of just HTTP. What HTTPS sadly is not solving is that it's opt-in, right? Whenever you type in a domain without the protocol, it will go to HTTP and not HTTPS. And that is even more or less undetected, right? The user isn't supposed to observe whether there's a lock or a no lock or a globe or a green lock or something completely different. So, and also HTTPS doesn't provide any guarantees to the full content of the web page, right? You may include images from other servers or ads or widgets or whatever, and they may not be loaded over HTTPS. So not everything is protected with HTTPS. We'll come back to this, but first I want to introduce you to something you may have heard of, which is called the same origin policy. So in 1996, when JavaScript was invented and frames, the idea was to have some sort of mashups in the web and include something as, well, let's say, as a component in your web page. And that means reusing existing code, which is always a good idea. But it was soon realized that it may be a bad idea if you're able to include something on a web page and read everything that is within it. Just imagine going to a web page that frames your bank statements, for example, and reads them. So of course, this is forbidden. And it was realized that we shouldn't allow that from other domains. Wait, no, not domains, but origins. So you have to be on the same origin. And what is an origin? Well, an origin is basically more than just the domain. It's the scheme and the host and the port of a URL. And we take that as a criterion to compare two things, basically the frame, the inner frame, the outer frame. So just to make it a bit more clear, I want to walk through a few examples. And I want this to be an interactive part, so please nod or shake your head if you agree or disagree. So I'm going to say first, this is the same origin. We'll always compare on the top right, example.com over HTTP, and there's another URL in the table. I hope it's big enough. What do you think? Is it the same origin? Please nod or shake your head. A lot of people are nodding. Of course it is the same origin. What about this one? HTTPS, exactly. Everybody's shaking their head. HTTPS is not HTTP. And what about the port, right? HTTP is using a different port than HTTPS. So what about this one? About blank. Well, the domain is not blank, right? Is about a domain? No. What's the port? What are we doing here? What do you guys think? Some people shake their head. A lot of non-that courageous people not doing anything. OK, I will reveal it for you. It is, in this case, actually mostly allowed. So if you frame something that is pointing to about blank, or if you open a pop-up to about blank, you have DOM access granted using JavaScript by writing stuff in it or reading stuff out of it, because everything that is in there is has basically probably been written by you, or it's just an empty page. I mean, what dangerous thing is there to read, right? It's surely not going to contain your bank statements. What about the next one here? Yeah, I see a thumbs down there. Yeah, the thing is, I've been tricking you a bit. Internet Explorer, for example, does not care about the port. And if you change document domain to some other value in JavaScript, all other browsers will also basically stop looking at ports. So to summarize the same origin policy, it is not as strict as we think. It's a bit weird, and it behaves differently for DOM access and XML HTTP request. For example, you wouldn't do an XML HTTP request to about blank, for example. So yeah, there's not just one same origin policy, but there are multiple scenarios you have to take into account, even though, in general, the policy just says port, domain, scheme. And there are also so many bypasses, right? You can opt out of the same origin policy using cross-origin resource sharing. And then there is JSONP, which is basically a hack that is meant to bypass the same origin policy, which I, by the way, don't recommend you to use. So if you want to learn more about the same origin policy and how it's weird, I can suggest you look at one of these talks. First one is by Brendan Eich, called The Same Origin Saga from 2012. The other one is from me because I had to write a very long thesis at my university about the same origin policy, which was presented at AppSec Research 2013 in Hamburg. But we'll come back to the topic of frames and how other domains interplay with your web application. But let's go on to the present. I want to talk about HTTPS again, and about frames. So to solve the thing that HTTPS was really just opt-in, there is something called HTTP strict transport security. And HTTPS was invented in 1994, and this here is from 2012. So we have finally realized that it's a bad idea to have HTTPS opt-in. So there is a way to enforce that the browser will always use HTTPS, no matter if the person sitting in front of the browser types in HTTPS or just the domain name. And it works like that. Usually you do start off with HTTP. And the client sends a request, the server responds, hopefully forwarding to HTTPS. And then once an HTTPS channel has established, the server is allowed to send a header that is called strict transport security. It comes with a time to live and basically says, hey, browser, please cache this for a certain amount of time. And whenever this time has not elapsed, continue using HTTPS when you talk to me. That's neat, right? So the browser will now always use HTTPS. But what about this one? It's plaintext again. What if there's a network attacker that is basically just stripping off the forward to HTTPS? And what if I tell you there are a lot of tools out there which are really easy to use, which are just doing that? They set up a proxy, everything is going through for you fine. And the user isn't actually using HTTPS if they are, again, for example, in the coffee shop. So to fill even this gap, there is a preload list in modern browsers. And actually, Firefox and Chrome basically share the implementation of the list and synchronize. And this preload list basically contains the bit here, let's cache this kind of thing. So the browser will always use HTTPS without requiring the first strict transport security header. But this list we have in the browsers, well, they are opt-in because we can't force other web applications into supporting HTTPS, of course. So to fill this list, a security engineer, Adam Langley, working at Google on HTTPS things, went around conferences, security conferences and other conferences, and said, hey, people, do you want to be on that list? It's awesome, it's secure, it's better than what you have right now. Just send me an email. And you know, this method to maintain the list, it scaled because nobody sent him an email. Yeah, you're laughing. I find that actually rather sad. So until just last month, when they set up a Google form, so I hope the mails coming in have either increased or you just got bored maintaining the list manually. But now there's a Google form and you can do it in a more automated way. But yeah, still, if you're using web applications and if you're providing them to somebody, and if you're already using HTTPS, please consider using strict transport security in your headers, as well as sending us an email to get into the preload list. So now I will come back to frames. So the threat model here I want to talk about is basically your website being framed by an evil website. So other than what we have before, somebody, like an innocent user, clicks on a link, goes to a website, and the website is evil and is trying to hack something, and it does include an iframe that is pointing to your website. So he's clicking around things, and you may have heard about this. This is called clickjacking, by the way. So there's like a non-transparent thing, an opaque thing on top. So he thinks he's clicking on your game or something, but actually he's clicking on your website and, I don't know, liking stuff. And there are much more evil things an attacker can do when they frame your website. Here's a funny thing from when the user is using Internet Explorer. So this meta tag is basically forcing the browser into an archaic rendering mode and legacy code, and probably also, or potentially at least, legacy vulnerabilities. So that means whenever somebody's going into the website that contains this meta tag, IE will say, oh, this is an old website. I have to be backwards compatible, so I will use rendering modes from Internet Explorer 7, which is about 7 years old. And of course, this is inherited to what frames. So if somebody goes to a website that is framing your website and they contain this meta tag, well, your website will totally behave differently, which is potentially bad, but it will definitely look bad. And there is more we can do with frames. I don't know if you've seen XSS filters and know how they work, so I'll recap about that. But a cross-site scripting filter built into the browser can help an attacker. So let's see, how do they work? The cross-site scripting filter is looking at the request as well as the response. And if there's something that looks like an attack, for example, a script tag that has been smuggled into the web page, the filter will say, hey, this script is exactly what has been in the response, and I'm pretty sure this is an attack. So I'll remove it or modify it so it isn't really passed as a script. And the user is secure, which is fine. But what if there was some static HTML or JavaScript that is in your web page, which somebody fakes as if it was in the response, but doesn't have any value for the web application, basically making up a fake parameter and sending it to the server. The server doesn't really work with it. It just ignores it because it's unknown and fake. But the browser would think, hey, this is the same. I'm going to remove it. Yeah, so what if this was a security feature, huh? So the solution to all these problems is basically disallow framing. You probably don't want your website to be framed. Why would you? The key is to just send a header with all your HTTP responses that says X frame options deny. If you do need framing sometimes, you can also pass in different other options that might be useful for me. Allow from or same origin. And luckily, you all know what same origin means now, right? So this framing thing is basically a security problem we've been having for 12 years. The first concerns were raised in 2002. The header itself was implemented in 2008, but the RFC was actually only published last year. And there is much, much more an evil person could do to your website and to the users of your website if you allow it to be displayed in the frame. I actually wrote a very long paper and a blog post with a friend of mine about it. There will be a link in the slides when I publish them, so if you're interested in that kind of nifty list of attacks, I recommend you look into that. Other than that, I want to jump forward into the future of browser security features. I will have to talk about frames again. I also want to mention cross-site scripting in general and how we can get rid of it for once and for all. And I want to talk about content delivery networks, which are so useful for our web pages. So first of all, how would we include untrusted content on our websites? Well, the threat model is here. We have to show something which is maybe a user upload or something from a third-party domain where we can't really control what it's doing, but we want to show it. Like, I don't know, a like button or something. Or in general, things that has been sent over HTTP because, well, a man in the middle, some network attacker could mess with it. And we all know that cross-site scripting, even just in the frame, can change the whole website and redirect the browser to something else. So to explain what we're going to do to solve this, I have to introduce you to the principle of not so much authority. The idea is to give frames access to the things that are only really necessary. And to explain what I mean, in system security theory, we are talking about the principle of least authority, which means an actor should only have access to all resources that it needs, but nothing more, just the least possible resources. But least authority in a browser world is kind of weird. It has actually been proven that HTML5 and CSS3 without JavaScript are Turing complete. So I wouldn't say least authority. Anyway, to solve this, there's a neat feature called iframe sandbox. And this really tiny attribute, just in your iframes, makes it really safe by default. It forbids scripts. It disallows forwarding and navigation of the outer window. No forms, no plugins. And no matter what the actual origin is of the content of the frame with regard to the outer window, it is considered as a unique and different origin, no matter what they are in real life. And if you want to mess with a sandbox and you do need scripts or plugins or something, you can make it a bit weaker. I'm not going through all the keywords. It's quite straightforward. Let's go on and talk about cross-site scripting and fixing once and for all. Who here knows about CSP? Who here is using CSP? Yes. That's the problem, right? Nobody is. But there are great introductions to how to make it work for your web application without having to rewrite everything. So there are two really good talks I recommend you look into if you're interested in adopting towards content security policy. First one is just last year, Mike West, and it was referenced multiple times throughout the day just by Tim, who stood here previously before me. So Mike's talk towards a post-XSS world explains CSP in a very, very long and comprehensive way. Really interesting. A colleague of mine, Mark Goodwin, went to SteelCon in Sheffield just a few months ago and basically tried to focus on the parts, not how CSP works and how it's supposed to work, but how to make it work for you, how to make sure that your web application is more secure without having to mess and rewrite all the full web application, basically providing a few developer tools as well. So due to timing constraints, I just want to say look into these talks. They are really good. It doesn't make any sense for me to repeat something that has been really well explained before. So as I said, I do want to talk about content delivery networks, where speed might trump security, right? Because you include a script from something that is not really under your control, and if you're paranoid enough, you may not really like it. But it's highly convenient, right? There is basically something that is most likely already in the browser cache of the users which are using a website, because other people are using the same content delivery network. So your website is faster, and that is nice. You want to have this. But what if somebody changes the file? Well, that means they can execute script on your web page and change everything. And due to the same origin policy, it doesn't mean just for this web page, but for all web pages in the same origin, because control. So the plan is, or the idea for the future is to lock it down with something that's called sub-resource integrity. This is yet to be a W3C specification. It's not completely done yet, and we are really looking for feedback, but this is how it looks like. It doesn't look really pretty, but what you do is basically you compute a hash of the file you intend to include. And if the file changes, well, you just don't load it. Problem might be, well, if jQuery doesn't work, the whole web application doesn't work. That's unfortunate, I would guess. So we have a fallback mechanism, of course. It doesn't look much more pretty, but it works like that. There is a non-canonical source, which is basically the fast bit, which is likely to be in the cache. And it's being tried to load by the browser. And the browser does all the checks for you, of course. It loads the script and checks if the hash matches, which is actually very, very likely. But if it doesn't match, well, the website isn't just going to break. It's just going to use the source from your domain, which is probably not on the cache, probably not as fast, but which can ensure that your website keeps on working. So as I said, feedback is really appreciated towards sub-resource integrity. We can also talk about it later after my talk. This is at an early stage. There is much more into it. I don't want to go through all the details, but if you think about using CDNs, this may be an option for you. So now I already want to conclude and say that the browser can help your web application. There are even more improvements on the horizon, like for example, sub-resource integrity. And even though the web evolved like this, which I, as a paranoid security person, might want to call chaotic, browser security has kind of evolved like this. There were some basic security checks in the front, like we are providing encryption, same origin fine, cross-origin not. There are cookies, and they kind of work. And then the web as a platform, as a rich applications platform, was adopted large scale, right? Between 1995 and now, everybody's basically using a website for something. So yeah, maybe we shouldn't just put the patches and bug fixes for security on top and try to think about it when developing new things. This is what I propose. But anyway, if you're concerned about your website because of X-frame options and strict transport security and all these things, there's a really nice dashboard which has been developed by my colleague Stefan Ahrens. It basically gives you a nice overview of the simple security features. And if your website looks rather red than green, then don't feel too bad. These are results from some Mozilla web pages. So, thank you very much for listening. If you have any questions, I will be at the Mozilla Hack Lounge in the second floor after this talk. I don't think there will be time for questions. Thanks a lot for listening.